Hi everyone. So here we'll be starting with our new data structure, which is a stack. Okay, so this will be an identification video, as well as this will be a video for beginners. To like wherein I'll let you know, guys, how do I see like when you get a question and how do I approach the question and then try to find out which algorithm or data structure it uses. Okay, so let's see. First, a basic introduction of a stack. What is a stack? So let's see that. Okay. Consider stack as some container which can hold values, pretty similar to array. As array can hold values, stack also can hold values. Okay. It also contains values. So consider this like some glass. It considers some glass. You are pouring in. You are trying to put in some elements. Let's say some marble glass. Some glasses of marbles or something like that sort. Okay, so what you do if you put something in first, it will go in last. I mean, if you put something in first, so it will come down here. Then whatever you put it will come down here, so whatever put it comes here. So now see, in this way, consider we are putting in this stream of elements. Okay, 5 4 3 8, something like this. Okay, so what happens? First 5 will go. First 5 will go here. Then on top of it 4 will go. First you tried entering 5, then you tried entering 4, then you tried entering 3, then 8. Okay, now finally you put in 8. So what will happen? As you see, I took the example of glass. Just think of that itself, that now what you can like remove first. Obviously you cannot break the glass and remove 5. Never ever it is going to be possible. So what you have to do, anyhow you have to remove the top element or the last element that you inputted first, sorry, that you inputted the last. You will remove that element. So what is the property? So let's see, if you remove, like if you're trying to get element from this, so it will be top element. So this is we call top element. Okay, the last element that is in this stack, it is top element. Okay, when we remove it, we say pop operation. Okay, we remove. So remove means we are done. Now see, now in this stack 8 is removed. So who is at the top right now? 3 is at the top. Okay, so there is one operation which we call, so you guys know top, you know pop. See, top will give you the element. Right now the top element is 3. It will not remove or do something, but pop will not give you any element. It will remove the top element. Okay, so this is done. Now there is one more operation which is push. Push. Now the thing that we did, we entered 5, right? We entered 4 3 8. So this is what we call push. So top, pop and push operations. Now see, so these three are the basic operations that we will always use, and there is like few more functions in it. You guys can see that we are having brackets, so that is why these are functions. Okay, there is one more function, size, size. Okay, so it will return you what is the size of this stack. Right now it is 3 when you are removed. Well, let's say you again call a pop, so it will again remove 3. Size is 2. There is one more function which is empty, which you will apply on this, like stack dot empty, whatever the name of this stack dot empty. So it will return whether the stack is empty or not. Like boolean value it will return. It will return some boolean value telling you that is it empty or not, true or false. Okay, so now see this, guys, the advantage of and other thing. So what this stack follows the property of LIFO, last in first out. You can see the whatever you entered in last 8, you are able to get it first. So last in first out. So this is the basic property. Okay, and this is what we'll try to abuse in all other questions. This property we'll try to use everywhere. Okay, now what I say, the major problem with the stack is you cannot like in normal array you can try and get some random index values. Okay, you can get 0 1 2 3 whatever. It's not mandatory that you have to start from here or you have to start from here only, then you will go. No, you can write in as square brackets anything what you want, any index what you want. But in the stack it is not the case. You have to go, if you have to find 4, so you have to go from 8, you have to remove this 8, then you have to remove this 3, then you will reach 4. Okay, only when something is top, only when something is at top, you can get that. And this is the problem with the stack, and this is also one of its feature. We'll see this in questions. Okay, we'll see this in this particular video, stack identification video. Okay, so what I say, it has this problem that you cannot jump into any indexes. So I hope this is a basic introduction of what this stack is all about. You can, guys who are coming from C++, this stack is available in HTL, and I hope that in Java also it is in collections library or somewhere, so you guys can see the syntax of it. But these three are the functions that I'll be using many a times in this playlist. So if you're okay with this, let's continue. Okay, now let me give you an example on the basis of that, and we'll try to solve that example, and then we'll see how to, like, what was the problem with our brute force, what are the problem with things that we are using, and which told us to go for some new data structure. Okay, right now, from now onwards to few minutes, I won't be taking the name of this stack. Okay, let's see. To continue with this example, I hope you should know these basics. You should be well in arrays and loops. That's it. If you know this, then you will easily get what is a stack. Nothing special I want. Now let's try to like solve an example which is valid parenthesis. This question, what it says, you are given a string of parentheses. You are given a string of two characters only. Which character? Either it can be opening parenthesis, which is opening bracket, or closing bracket. That's it. You will be given a sequence of it. You will be given a sequence. Okay, you have to give return. You have to return, is it valid or not? Right now, how can you say this is valid? For those guys who don't know how to say valid or invalid, remember this in elementary mathematics or in or college days. What how we do? Remember that bracket rule. We have to first solve inner brackets. Okay, let's see, 4 plus 5 into 6, then into 7. So how would you solve this? If you see an open bracket, you'll go inside. If you see an open bracket, you will go inside. Now see, now you are if you go inside, there's no opening bracket, there is a closing bracket. So whatever is between this innermost opening and closing, you will solve it first, then you will resolve it. You will write 9, then 9 into 6, whatever is, and then in this range, like in this bounds, opening and closing. So in this way, what you do, you'll try to see the innermost, like when you're getting an opening, you go inside. Whenever you get an opening bracket, you go inside. Whenever you get an opening bracket, you go inside. As soon as you encounter a closing bracket, so whatever this closing bracket is, see guys, this closing bracket, what it requires the nearest opening bracket to get paired up, nearest opening bracket. So whatever is in between this closing and its nearest opening, you will try to solve it first, then you'll finish it, then you'll say this bracket is done, you'll write this number. So this is what we do in mathematics, correct? Here also we'll do the same thing. This is what we carried from elementary schools or in college days. So let's try to find this, let's try to solve this. So you encountered opening bracket, no problem, let's go inside. You get a opening one, no problem, let's go inside. Okay, you got a closing one. Now because this closing you got, and what you need, because once you get a closing, you cannot go forward before, like before neutralizing it. So what you want before this closing, is there any opening? And whatever opening I am getting, I need the latest opening, the last opening that I'm getting. So for this closing, guys, there are two openings, this one and this one. Which opening do you think this closing will want? Obviously the latest opening. So last opening. So this word, guys, remember, mark it. Okay, so we'll use this. So this closing will finish this closing will finish this, and then also this one be gone. Okay, so there are many, like in this way, if all the openings and closings are getting resolved, you say this is a valid parenthesis. You will return what? True. You will return true, that this is valid. Now what are invalids? Consider this example, a simpler one. Or so the best thing, guys, if you get a closing bracket, like as soon as you start traversing this, obviously this is a string, which means it is an array of characters. Okay, character ka array hai, nothing else, nothing special. Okay, now see, this is closing bracket. When you get a closing bracket, you cannot go past it. Okay, you cannot go beyond it. You have to neutralize it. You have to find an opening bracket to its left, and that to the latest opening bracket, but it does not have any opening bracket. So right here at this moment, you will say it is false, it is not a valid parenthesis. Okay, so what are other examples? Maybe like this, these two are neutralized, but what about this? And even if you're getting extra opening bracket, then also it will create issues. Look, this two are resolved. What about this? So these all are your invalid parenthesis set, so they will return you false. Okay, now let's try and solve one example. So this is, I hope this is what how it was solved. Like, first we realized what are our invalid test cases, what are our valid test cases. Now let's try to solve it in brute force, in the most gruesome way that we can, and then we'll see what are the problems. What are the problems that it is offering to us. So let's say we are given this test case. Okay, you are given this test case. So you have to find or you have to tell me whether this is valid or not. Obviously, by seeing with our naked eyes, it seems to be valid. But how in coding, how in programming you'll depict this picture, how in programming you'll put on this on the C in using C++, Java, or Python, or whatever language you prefer. Now let's try to first find what we were doing. So when you are getting an opening, you never bothered about closing it at first. You'll go, like here you saw, guys, in simple mathematics, whenever you get opening, you go inside it. You go one level deep. You don't bother about closing it at that moment, okay, because you think that you might get a closing. So this opening is not problem, is not creating problem. This opening is not creating problem. This opening is not creating problem. As soon as you go to index number 3, you get a closing. Now what do you want? You want an opening bracket. As soon as you get closing, you cannot, because look, once you get a closing, you can't say that I can get opening later. So this is invalid. Once you get a closing, you want an opening to its left. Okay, so once you get a closing, you want an opening to its left, and that to the nearest or the latest or the last opening. And which is the last opening? This one is the last opening. So what I say, this opening is done. So let me resolve this. Let me say that these two are done. They are done. So this opening is also done. Okay, now let's go ahead. After 3 you'll go to 4. After 3 you'll go to 4. So this 4 is also a closing bracket, a closing parenthesis. So it will also require what? An opening bracket in its left, that to the latest one. It will also require the latest opening. Now see what you will do, guys. What you will do, because you cannot go to right, obviously, because you going in right direction, searching opening bracket is of no use. So you will start, see, once you get a closing, once you get, so right, if you see this properly, what are we doing? We're iterating from zero index to last index, and wherever we find a closing, we will try to search an opening in its left. So again we found a closing. What we'll do, we'll start from this index. Let's say this index was, like, this variable was I, which started from 0, then it goes to 1, 2, 3, 4. Right now when I is at 4, you'll start a loop from I minus 1. Let's call it j. Okay, now this j has to do what? This j has to give you an opening bracket. And guys, if you can observe here, so what do you want? An opening bracket. Now this is not an opening, so you'll go here. Okay, so this is opening, and this is also the nearest opening. Look, for this particular closing, this one is the nearest opening. But guys, do you think that this opening can be used for this? No. Why? Because this opening is already resolved using this. This opening is already resolved using this. So what you can do at best, what you can do at your best right now, because we don't know any other data structure or such, we have to go with arrays and loops only. So what I say, what I'll do, when closed this, when I said that this opening was paired up with this closing, as this was character array, so this opening should not be used by anyone else. Once this opening was used by this closing, this opening should not be used by anyone else. Okay, but if so, what we have to do, we have to somehow, because this is all obviously this is a character, this is some character, because this is array of character. So this is some character, getting it, guys? This is some character. So what I can say, I will replace this opening bracket, because when I'm sure that this opening bracket is is paired up, it is being neutralized with some closing bracket, and I don't want to let it be right like this, like opening, because it will tell it will say that I am opening bracket, so anyone can use it. No, I will tell that this opening is done. I will replace this opening with some character like this. So let me replace this with like this character. So let me write even a new one, so that it will not create uh, like a garbage thing. So now what happens, you were at where? You were at index number 4. Okay, so for 4, look, for 3 you were done. That is why you went to 4, because for 3 you got an opening bracket, and that was at number 2. But right now it's 2 number opening is already being used. It is already being neutralized. So I inserted this value in place of opening, so that if anyone else is going in this direction, he or she won't be getting the index 2 as opening. Now see guys, let us go with our example. Let's continue. So here in 4, if you are at index number 4, so 4 was your opening, sorry, closing. So you will go I minus 1, and you will start a loop in this region, and you will find what the nearest closing, not let's go nearest opening, sorry, nearest opening. So is this opening? No. Is this opening? No. Earlier it was opening, but right now it's not. Do you think this character looks like this? No, obviously not. So you will go here. Okay, so this character looks like this, opening bracket. So you say, okay, I got this. And if you see guys carefully, so this closing will obviously pair up with this opening. So again, this opening is done. So this opening will be paired up with whom? This closing. So what I'll say, I don't, because this is already paired. So obviously you'll go one step ahead. But what you have to do, you have to make sure that this opening should not be used by anyone else, only for this. So again, you will also convert it to this hyphen sign. Okay. Now what will happen? If you see, let me write this test case like this. So now what we'll do, because you were at this 4th index, see, stay up. So you were at this 4th index. I believe I wrote something right. Sorry, you will be at 5 index. 4 was done already. Okay, just give me a second, guys. So you were at because 4th index is done, so you will be at 5th index. Now let's go to 5th index. This is a closing bracket. Again, what it wants in this region, in this I minus 1 region, it wants an opening bracket, and that too it should be the latest one. Okay, so you will go here. Is it opening? No. Opening? No. This is not even opening or not closing. This is nothing, because here they were openings, but we should not use them, right? That is why we inserted hyphen here. That is why we inserted hyphen, because it will not require any effort, because it is an array of characters. So we can put anything, any character we want. So you will go here, you will find, okay, you will find a closing bracket, oh, sorry, opening bracket. You will say, I've also found this, I have converted to hyphen sign, and you are done traversing this entire string. So you will say, I returned yes, or I returned true, it is valid. Okay, let's observe what all things. First of all, what is the complexity that you guys can think for this time complexity? The first outer loop, because we are using 2 loops. Okay, the first outer loop, it will go from 0 to n. So it will take it will do n like n times. It will go like n times 0 to n. I mean, like for n elements it will check. For n elements it will check. So there are n steps that it will follow, and for every step inside it has potential. Let's say if you're checking for 3, it has potential to go till where 0, because we were checking in this region. So it has potential to go to last. Okay, so it has potential to go last. So what I say, if you are in index number 3, how many traversals you can do, how many checks you can do? Obviously 3 checks. Okay, 3 checks. Here see, here guys, you found your closing opening bracket at index number 2, but it's not always the case. So all in all, I'll come back to this, how to calculate this complexity and all. But believe me, because you are having 2 loops, and the outer loop is going for n steps, and the inner loop will also be having the potential to go to 0th. So it will also, you can also say roughly that it will also go n times. So n cross n, which is n square. So order of n square complexity, time complexity you're getting here. Now let's try and observe, can we reduce this complexity? What are the things, guys? I hope, first of all, this video may be a bit lengthier, on a lengthier side, but I want to tell like all the intermediate and all, especially the beginner guys, how to approach a problem. If you are getting some problem, don't directly jump to any conclusion, right? I need this data structure, and I need this algorithm. No, try to find what are the problems, your pre-existing solution that you used. Now let's see, in array, what was the problem? Look, first thing, when you encountered a closing, what all you do, look, when you encountered opening, you don't bother about it. You will go right, you will go one step right, that's it. So when you get a opening, you'll go one step right, so you are not bothered about opening right here. Okay, but when you encountered a closing, what do you want? The nearest opening, or I can say nearest valid opening. Okay, because see, when you got this closing, this opening was finished. So this opening was not valid anymore for any other closing brackets. So when this closing came, it cannot be paired with this opening. So that is why I said it want what you want, the nearest valid opening bracket, the nearest valid opening bracket. And let's see second thing. And why are we doing this much of comparisons? See guys, if you guys can remember this, let me erase this a bit for you, so you can try and get it in good way. Now see, when you get this closing bracket, you neutralize this opening. You said that this opening cannot be used by anyone else. But see guys, for this closing anyways you have to, like, because this is an array and you will go one step at a time. Okay, because you don't know where your opening is and what is that thing. So obviously you did what you did, you converted this opening into this hyphen so that no other closing can use it. So but what you will do, you'll go one step at a time. For this opening you'll check this is not an opening. This was an opening earlier, but now it's not. Okay, so then you will reach here. So look, you are checking these two guys, you are checking these two guys again. Is there a need to check them? Because obviously they are done traversing. I mean they are neutralized. So we know that they will not they'll not contribute to neutralize this closing. We know that they will not contribute to neutralize this closing. So what I can say, we are doing unnecessary comparisons. Unnecessary, I think my spelling may be wrong. Unnecessary comparisons, we are doing unnecessary comparisons. Okay, and see, so can we reduce, because see guys, now for this closing you got this opening was done. Okay, now see, for this closing again, you know that everything in this region, everything in this zone, they are done, they are neutralized, they are paired up. Okay, so you know none of the brackets here are available to anyone else. None of the brackets in this region, in this amongst these four brackets, they are not available to anyone. Now for this closing you don't know that, right? In array you don't know that, so you will go one step at a time. You will see this, then you will reach your desired opening. So as I said, you are doing unnecessary comparisons. So let us try to create a new data structure for that. Because in array you saw, because you are going one step at a time. And why? Because you don't know where your opening is. That is why you are going linearly. So these two are your these two observations, whatever we saw, they will help you to get new data structure. Now let's try and find that. So let me use a new data structure. And what will be the property of it? Because array is not the way to go, because in array you are doing unnecessary comparisons. We can avoid that, and let's see how to avoid that. So first thing, the property, what would be the property of this data structure? Because see, uh, if you keep this string as it is, you were just traversing from left to right, you were just traversing from left to right. So and what are you bothered about? Whenever you get a closing, you need an opening. Whenever you get a closing, you need an opening. So you, in new data structure, what we want only openings. Opening brackets. Why? Because when you get a opening bracket, you're not bothering about closing it right now. You'll go to right. But when you get a closing bracket, you know you have to close it. That is why you will have to get an opening bracket, and that to nearest. So 0 1 2 3 4 and 5, let's write the indexes. So what is the what will be this data structure used for? First of all, this new container, it will be used for holding only the opening brackets, because we want only opening brackets. And guys, that too in what fashion? Let's try to find this. So 0 is the opening, so write 0 here. 1 is the opening, write one here, because we are trying to put all the opening. 2 is opening here, so okay, no problem. Guys, don't say this picture with what earlier I draw here. Don't compare it right now, we'll come back. Okay, so right now you can remove, and like from any end, here or here. Consider this, it is flexible, you can remove from any end. Okay, you can remove element from any end. Now you got 3. So you know 3 is closing. So it has to be paired up with whom? The nearest opening. And guys, as I said earlier, you have the option to remove from any end. and you want the nearest opening or the last opening. So where, from which part, from top or bottom, from which part you will remove the element? Obviously, because for 3 you want 2. Getting it, guys? For 3 you want the last opening, you want the nearest or last opening. So you will say for 3, 2 is your opening, 2 is your opening. And guys, so first thing is this. So for this, in this data structure, you will have the capability to push elements, and that too in which way? That whatever you entered last, it will come first, it will be at top. Because for 3 you want the nearest opening, which is 2, not 1 and 0. So I hope this thing is clear. Now see, second thing, and the best thing, why were you doing unnecessary comparisons? Because you look, whenever you were having opening here, so you replace this opening with hyphen. Okay, but then also for this 4, you will go and check 3, you will go and check 2, then you will land here. Okay, so because these elements were there, so that is why, because you don't know where to go, so that is why you were going one step linearly. Okay, but what I say, we have to avoid this unnecessary comparison. We don't want that. Because if somehow we can get the information that for this 4, who is your nearest opening or nearest valid opening. Now see, 2 was done. What I say, guys, 2 was 2, because this is an opening bracket. This entire thing in this structure, everyone is opening bracket. Okay, at what index is 0, 1 and 2. So because 3 has paired, like 3 is being paired up with 2, so 2 is not available to anyone else. 2 is not available to anyone else. So what I can do, let me remove this. Why? Because I don't want comparisons, I don't want unnecessary comparisons anymore. So if 4 will come, it won't have to check with 2. So because in array you cannot remove that element, you have to anyway cross this element one after another. So let me remove this. So what I need, a data structure with property of push and a property of remove, or we can say in a better way, pop. We want the property of pop. So let me remove 2. So 2 is removed. Now when you get 4, so this is also closing. So what it wants, an opening to its left, and that too it should be valid. And whatever in this structure is, they are they are following this order, last and first out. So whatever you are getting at top, it will be, and it is also valid, because all the invalid openings, we are removing them. Once these openings are paired up, we are removing them. So for this 4, who is your last opening? The one index, which is this opening. So you also remove it, because you're done with this. For 5, who is the last opening? Obviously 4. So now see, the stack is empty, so which means no opening brackets are remaining. This string is also done traversing. Then you can say that I am returning true. I am return, if any one of it. See, once you've done the traversal of this string, so either like you got a closing bracket for which there was no opening, that might be the case. Or if you're done traversing this string, and this particular structure is having some element, so which means these remaining elements, or these remaining opening brackets, they don't find any closing. Okay, so I hope in this way you got that our array was creating issues. So because it was doing unnecessary comparisons, and what only we only wanted to get this. For a closing, we wanted the nearest opening. I hope then what we I hope you are getting it, guys. Then what we saw, we went for a new data structure using that we want, like, to avoid unnecessary comparisons. And how we remove that unnecessary comparisons? By keeping the elements in last and first out. So we directly get the last encountered opening. And plus what also we did, we removed that. Okay, so that no other closing bracket can even compare with it, because this is invalid, so we'll remove that. So let's see, is there any data structure that offers us this property, push, pop, and this LIFO thing? I know, guys, you can guess it. Obviously it is a stack. It can offer you LIFO, push, pop, and the last element is top. Okay, so I hope from here onwards you are clear with why to go with stack on this particular problem. Where? On this valid parenthesis problem. Okay, now let's try to generalize on so I hope you are, for the beginner, this video was, guys, for the begin, like, the most beginner friendly that I can make, just to make you realize that what was the problem. See, guys, don't directly jump on stack that, yeah, this problem will be solved using stack. If someone comes and just draws to you like, let's use array, let's enter opening bracket, let's go with closing. No, why are you going with this stack? What was the problem with your normal array? Can you tell us? So then go with this. In this way, this identification part is no more problem to you. You don't need any tips and tricks that if you're seeing this pattern only, then go with the stack. No, you first of all, you should not even be bothered about going with the stack. See what is the problem with your array and how can you abuse this property of stack, which is LIFO. Once you see that in particular problem I need LIFO, some sort of like some sort of data structure where I can, like where I can use this LIFO thing. That if you see this problem, it was telling you, it was telling you that you have to use some data structure. You cannot go with array. You have to use some data structure which is having LIFO property, where you can remove elements, where you can push elements. So this problem itself, the test case itself yelled at you. It told you कि भाई मुझे LIFO वाला चाहिए, कोई मुझे array नहीं चाहिए. So यहाँ से तुम्हें ऑलरेडी पता पड़ जाएगा कि ये स्टैक ही है. तो अब तुम्हें और कोई शंका तो नहीं रह जाएगी ना कि इसमें स्टैक ऐसा कैसे आइडेंटिफाई करें. अगर इतना तो गधा मतलब मैं था वैसे, बट आप लोग तो नहीं हो कि भाई लीफो बोलने के बाद भी, पुश बोलने के बाद भी खुद क्वेश्चन ने बोल दिया कि मुझे लीफो वाला चाहिए. सो दैट्स इट. ओके, नाउ लेट्स सी व्हाट ऑल ऑब्जर्व, like what all the key points, or I can say now I'll give you tips and tricks where you can use that stack. Okay, so first and primary thing, forget about tips and tricks right now. The basic point of a stack, it is LIFO. In problems, if you see that, let's say mostly they will be of array, mostly they will be of array. So in problem, if you see, while going one step, so let's try to find answer for this. So like here, if it was a closing bracket on in some, in problems, for this element you have to decide, for this element some sort of answer. So if you have to decide this element's answer, if you have to decide its element answer, and in that case what you can do, like you, because this is an array, so if you see that it tells you to use the last element, so in that case obviously LIFO is the thing. So you'll get this clue from this question itself, that for elements, for this to solve this array individually, for all the elements you want their answers. Let's say here it was the closing bracket, for them you wanted the opening bracket. You'll get all the questions like this, where if you're getting the hint of LIFO in your structure, while solving your problem in brute force, if you're getting this hint of LIFO, so this is the best clue, because LIFO, no one can else offer you LIFO. Okay, so LIFO was the first thing. Second thing is, why are we going then for a stack? Because LIFO can be, let's say we are having LIFO, so this was the best clue, but let's see what other things was there. So obviously what will happen guys, in array, while you're doing brute force, mostly it will be of order of n square complexity. Mostly it will be the time complexity will be order of n square. And in cases where you are getting LIFO, we'll reduce this to order of n. That is why we'll use a stack. And you see, we reduce the time complexity, which means we reduce the number of comparisons, because who increases the complexity? Mostly comparisons, number of comparisons. So we have to remove the number of comparisons. How can we remove them? While going, let's see guys, while going for, like, while traversing this array from left to right, once you encountered some element, then you go to other element, like in this way. So while encountering elements, you can actually decide were they of any importance to you or not. For other elements, are they of any importance? Like, is there any importance remaining for them or not? What I mean by this, see, once you encounter this closing, when you encounter this closing, and then you paired up with this, so these two elements of no use. So this opening cannot be used for like by any other closing. So in this way, you see that this opening is of no use. So that is what I'm saying. You will see that few elements are unnecessary, or are not required anymore, and that is where you will use the property of LIFO, and you will pop them. You'll pop the top element. Okay, so these are the two basic hints that you will get the hint of, you will get the clue of LIFO from test cases, that LIFO, in this way you have to solve. Okay, I need the last element. So all this sort of thing, all this sort of clue, last or latest, or in this way, or the nearest. Here you saw the nearest opening we wanted. What do you mean by nearest opening? While going from left to right, what do you mean by nearest opening? Nearest opening means the last opening that you encountered. Second thing is, because you need to remove the number of comparisons to go to order of n solution. And how to remove the number of comparisons? remove the elements itself. So you will get to decide if I can remove elements. Here you saw that opening was not required anymore. And so these were basic things. Now let's see the third, which you can say a clue. And I hope this thing like Aditya Verma bhaiya also told in his video, one of the identification video on stack. So okay, so if you see, how are we solving the problem in brute force of this string of this parenthesis? How are we solving in brute force? Obviously, you're going from I assign 0 to a dot size, which was from here to here. Then as soon as you encounter a closing bracket, which means, let's say you encounter this closing bracket. So what you'll do? You'll start traversing from its left to here in this region. So that what we are doing. So once you get an opening, once as soon as you get an opening, you'll neutralize it. You will say this opening is done, this is hyphen, you will break, like this is all we saw. But can you see the nature of this traversal? So for this index, you are going here, not right, which means for every index you will not go to every other index. You will go to some part, either left of it, either right of it. So what I mean, for every index, for every index you will go, you will go either left part or right part. Okay, so what it means, like there will be a pattern, like for here, for this element, for this index you will go here, for this element you will go here, not to the left. So in this way, okay, for every element you will go either left or either right. So this is also you can call dynamic traversal of array. So I hope guys this video I kept a bit lengthy for those who are directly coming in this video and like thinking of that bhaiya will tell something magical. No, yeah, nothing is magical. There is no secret ingredient. I hope you guys saw that movie Kung Fu Panda. कोई सीक्रेट इंग्रेडिएंट कुछ ऐसा नहीं होता, तुमको रटना ही नहीं है कुछ यार, यू डोंट हैव टू लाइक, तुमको रटना कुछ नहीं है, स्टैक स्टैक सब कुछ एक बेसिक चीज़ है. तुमने देखा मैंने क्या बोला कि भाई एरे से मुझे प्रॉब्लम हो रही थी, ये सब प्रॉब्लम्स थी मेरे पास एरे में. तो मैंने क्या सोचा कि यार चलो एक नया डेटा स्ट्रक्चर बना के देख लेते हैं. अब मैंने जब डेटा स्ट्रक्चर बनाया, मुझे सारी प्रॉपर्टीज़ चाहिए थी उसमें से. तो अगर ऑलरेडी प्रेजेंट है तो ठीक है, और ये प्रॉपर्टीज़ किसी एक में है, वो है स्टैक, तो मैंने यूज़ कर लिया. सो ऐसे ही इन दिस वे यार, इन दिस वे एवरीथिंग इन एवरी क्वेश्चन, एटलीस्ट मैं अपनी वीडियोस ऐसे रखूंगा कि भाई तुम्हें हर एक चीज़ क्लियर करवाऊंगा. यूँ नहीं कि भाई आते से चलो स्टैक धमाधम बना दिए, ठीक है. देखो किसी को क्रिटिसाइज नहीं करना है अपने को, बट द थिंग इज यार, देखो जब आदित्य वर्मा भाई आए थे उन्होंने क्या चीज़ बोली थी कि जो तुषार सर थे. अब देखो सबको एक दूसरे ने देखा ही है. जब कोई नहीं था तब तुषार सर थे, तब अब्दुल बारी सर थे. तो आदित्य वर्मा भैया ने क्या बोला कि तुषार सर आते ही 2D मैट्रिक्स बनाते थे, ठीक है, डीपी के लिए धड़ाधड़. तो अब बताओ, अब फिल करते थे, तो अब डीपी ये बना कैसे? तो ऐसे मैंने काफ़ियों को देखा है. तो आदित्य वर्मा भैया का ये चीज़ था कि यार तुम्हें डीपी क्या बनाते हो. तो अब मेरा ये चीज़ है कि तुम आते ही स्ट्रक्चर क्या बोल देते हो कि इसमें स्टैक चाहिए, इसमें क्यू चाहिए, इसमें लिंक लिस्ट, सॉरी लिंक लिस्ट दिख जाएगा, इसमें 2 पॉइंटर चाहिए. बोल कैसे देते हो मुझे नहीं पता यार. मैं देखो मैं से बताऊँ, मैं टीयर 333 कॉलेज से हूँ. 3 भूल जाओ, 33 भूल जाओ, 333 कॉलेज. मुझे कुछ नहीं आता यार. मुझे जब तक तुम समझाओगे नहीं ना एक एक चीज़, मैं इतना गधा हूँ कि मैं उसको या तो मैं रट ही लूँगा. मेरे को समझ नहीं आता, मेरे को हिंट समझ नहीं आती, इसलिए मैं हर चीज़ को इतने डेप्थ तक जा करके आई डाइसेक्ट ऑल द क्वेश्चंस. सो दिस चैनल इज मेनली फोकस्ड फॉर द गाइज लाइक मी हु आर इतने डम कि पूछो मत. ठीक, चलो. सो आई होप दिस वीडियो क्लियर टू यू गाइज. लेट मी नो इन कमेंट्स. तो थोड़ी लेंदी थी, आई नो यार, तुम जिनको आता हो थोड़ा भागा भागा के देख लेना. ऑब्वियसली स्पीड 1.5x रखना, मैं काफ़ी स्लो बोलता हूँ. लेट्स मीट इन अनदर वीडियो.